So this is a lesson is about linear functions versus exponential functions. It almost sounds like they should be superheroes, and linear is competing against exponential. But we're not actually competing. We're just looking at the differences and the similarities among them. So with linear functions, we know that this is y equals mx plus b. And m, of course, is slope. It's the rate of change. And that's important when we're comparing. Okay, so slope, rate of change. Okay, and that's going to be a common difference. Now when we say difference, we of course mean that we're subtracting. Can you even read that? That says difference if you're wondering. So common difference. Common difference. And that's going to play into how we tell the difference between a linear and an exponential. So when we say a common difference, it's going to be that it's added or subtracted to the one before it. Whereas b, that's going to be our y-intercept, of course. It's going to also be our zero term. And you know that when we graph, that's where we begin. So we know that this is the initial value on a lot of them. Okay? Now, if we look at an exponential function, this is a, and this is b. And we know that a is the initial value. And we know that initial value, which means that it's going to also be the y-intercept. If it's in the parent function, that's as if there's no shifts or anything like that. And we also know that's going to be the zero term. I don't know why I hyphenated that. Just a zero term. Okay? Now, we know that b is what it changes by. So this is our rate. You know, like when we were talking about exponential growth and decay, that was our rate. It's also our factor of change. Now think about factors. If I think about the factor of 12, 3 is a factor of 12. I multiply 3 times something. So this is a multiplication, which makes sense because here we have addition, here we have multiplication, so it totally makes sense. So one of the ways that you're going to see this, and this is a lot, you'll see this on your practice EOC test, is it wants you to compare tables and to be able to identify how do you know which table is what. So that's where I want you to go to that other sheet that I've given you. Looks like this, identifying types of functions from a table. And now we're going to also pull in quadratics. So we have the linear equations and we have a constant of first difference, and that's going to be important when we're talking about the table. A quadratic, the constant is the second difference, and I'll explain. And then the exponential has a constant ratio, so you're going to multiply. Okay? So here is a linear function. Where did my linear go? Okay, well, hold on one second. So what happened is all the typing is going off. I knew this one was my linear, so I'm not sure what all of this is about. Just kind of ignore that. Those all got messed up as far as spacing. See how it changes by 1? Okay? It goes down. It can go down or up. It doesn't matter. I know we said common difference, but down or up. So this one is linear because that's how it goes down or up. How does it change? And it's an addition or subtraction. Now this one is a quadratic. And the quadratic, remember, it's a power of 2. And so it takes 2 levels in order to get to where it is the same. So you're going to do a first level and you're going to say nothing is the same. But then when you look at this, what happens here? It's on the second level. That's what makes it the quadratic. This is what is the same, that second level. And then this one's an exponential. Now they kind of give it away because they tell you it's an exponential. But what we want you to see is, what do I do to 6 to get to 18? I could add 12, but do I add 12 here? No, I'm multiplying. So you kind of have to look at one and then also the next one too. So that's what we're looking at as far as what is happening. And so I want us to look at these tables. And we're just going to try a couple. So we look at this first one. What am I doing to 7 to get to 4? Well, I'm subtracting 3. What do I do to 4 to get to 1? Oh, this is looking promising. I'm subtracting 3. Do I subtract 3 here? Yes, I do. And do I subtract 3? Oh, so what do we know this is? Well, it's the first level, and we added or subtracted, so we know this one is linear. Okay? Now look at this, 1.5 to 3. I would add 1.3. Well, that's not going to, 1.5. So if I could add 1.5, but do I add 1.5 there? Nope. So that's not going to be addition. What do you see? Right, you're going to multiply by 2. If I multiply by 2, 3 times 2, is that 6? Yep, and if I multiply, so what do we know this is? Well, it's multiplication. Therefore, it's an exponential. Okay? So look at C. What's happening on C? What happens from here to here? And from there to there? And from there to there? Hopefully you said add 18. Okay? Now I want to point out a couple things. So this one is linear. I want to point out a couple things on these. Look at these first two. See how they change by 1? This goes up by 1, goes up by 1, goes up by 1, goes up by 1. So this is all a plus 1. This one's a plus 1. This one is a plus 2. It still doesn't matter how this goes up. It's still going to be linear as long as it is constant. This has to be the same distance from here to here and from here to here. So this goes up by 2. And this goes up by 2. And this goes up by 2. So you might remember that's how we could find slope. So this is a linear. If I wanted to find slope on this, I could take my y value of 18, divide it by my x value. My slope is 9. Okay? So that's how you can find slope. So over here, what's my slope? Well, I take my y value over my x value. My slope is -3. Okay? So just an added bonus there. Exponential, this would actually be your rate. So if I were doing this equation, I would have an A. Oh, that's my initial amount. We can actually write the equation for this. See this right here? That's my initial amount. So that's 3. What's my rate of change? It's 2 to the x. So we can actually write equations. Over here, what's my y? Exactly. So that means that this is going to be my y-intercept. My slope is -3x. Okay? So just kind of keep your eye out for those. That's really helpful. This one we don't know the y-intercept, but we could find it. Okay, I'm probably getting off subject a little, but this could show up in EOC. So from here to here is 2. If I want to go to 0, how much did I change? I changed by 1. Okay, so if I changed by 1 here, I went down by half as much here. Okay, and so halfway in between would be 9, so that gives me 0, 0. So my y-intercept on that is going to be 0. Okay, so that equation, y is equal to 9x, because my y-intercept is 0. Because if I go down from -1 to 0 is 1, so I go half as much down here, and I end up at 0, -9, go half down, go 9 down. Okay, so look at this one. Okay, it's going 1 apart, but what is it changing here? Well, it's changing, it's going down by 3. It's going down by 1. Now it's going up by 1. That's a clue too, you'll see. Going up by 3. Okay, so now, hold on, look at this. Look at what changes here. From -3 to -1, what does it change? 2. Goes up by 2. Goes up by 2. Goes up by 2. Bam! That's a quadratic. Okay? So that's a quadratic equation. And the other thing about quadratic, see how it goes 6, 3, 2, 3, 6, how it goes. So just like a parabola, it goes down and it comes back up. It goes down and it comes back up. Your y values go down and come back up. They might go the other way too. But just kind of, I wanted you to see this. This will show up. This will be very helpful because I know you'll have one in your practice test that asks you to identify from a table what kind of function do you have. Okay, so let's go back to what we're talking about here. It goes right along with what I was just showing you. Let's look at what's happening on this one. So here we go. We know it's a linear, so we know what's going to happen. So it's kind of like blows the ending. So sorry, spoiler alert. Okay, what does it change here? It goes up by 3. What does it change here? Up by 3. Up by 3. Up by 3. Okay, and we're changing over here up by 1. Up by 1. So this tells us right here it's a linear because the first level is just changing by 1. So we can actually write the equation for this. Okay, so look at our slope. Our slope is going to be y over x, so it's going to be 3 over 1, so that's our slope. Okay, and then we're going to find out what's our y-intercept. Where does it cross the y-axis? Right there, because my x-coordinate is 0, so that's my y-axis. So there's my equation. Isn't that cool? Just from that table, we can figure out what the equation is, so that's pretty cool. Let's look at this one. Okay, this is not as obvious to me right here. So what I did is I went down here. What am I doing to go from here to here? Well, I'm multiplying by 3, because I know I'm not going to be adding with those fractions. Do I multiply by 3 here? Yeah. You know that you're going to multiply by 3 here. Look, to go from here to here, take 2/3 times 3. See how that gives me, my 3's cancel and I just get a 2. So we know that we're multiplying by 3 every single time. And if you want to, take 2/9 just to prove it to yourself. And that gives me 6/9, okay, which gives me 2/3, which is what I got right there when I multiplied by 3. So that is my rate of change. So that is my B. And then what we have to do is, where does it cross? What is the initial amount? What is the initial amount? It's 2. But this is an exponential because we had to multiply. So it's 2/3. It's 2 times 3 to the x. Okay? Questions? Okay, now let's graph these. So we're going to pause. Everybody's going to pause, and we're going to graph these points. Plot these points on these graphs. Go. So once you plot them, you can see what their shapes would be, and we've already been talking about these. So here's a exponential. Linear, we haven't done these for a while. Now, I didn't actually plot the points. I don't know about you guys, but I used the y-intercept. I plotted the 2, and they went up 3/1, down 3/1. I didn't plot the points. So, not trying to get out any work, but remember, we can just plot this and then use my slope, up 3/1. Okay, now let's talk domain and range, just because we should always talk domain and range. So what's happening with my x values? Any restrictions? Nope. Any restrictions on y? Nope. So therefore, I have my domain is -infinity to infinity. My range is -infinity to infinity, and that's usually true with lines. Now with exponentials, we know what happens. We have that asymptote. And our asymptote right here, because I didn't have a plus or a minus, okay, it didn't shift up and down, so I know that my asymptote is going to be, my horizontal asymptote is going to be x equals 0. Sorry, that should be y. I've been telling you wrong all along. That is a y. Y, it's crossing the y-axis. Oh my gosh. Okay, I'll have to put a disclaimer. It should be y equals for your asymptote. So, keep that in mind when I go to domain and range. Any restrictions on our x? Nope. Any restrictions on our y? Well, huge one. We can't cross that. We can't even touch it. So we know that our range is going to go from 0 to infinity. Okay? Good. Let's look at the homework on the next page. So determine whether the following equation represents an exponential equation and explain. And actually, I'd like you to kind of identify which one's which, and you should be able to identify which one is linear and which one's exponential. I'll let you look at that. Here we go with tables. The only difference with the table is the x and the y are like this. So you're just going to have to see what's happening with y here, what's happening with y here. Now notice this goes up 1, 2, there's 1 apart. This goes up 2 apart. It's still not going to make any difference to determine what it is. So we want you to tell us if it's linear or exponential, and how do you know that? How do you know that? Then evaluate the function. You've done this 20 million times. Okay, number 10 is a fun one, because number 10 you're going to actually match the equation. So this is obviously an exponential, okay, and it's going to go up. Okay, this is an exponential, but it has that certain stretch. So that's going to talk about the initial value. Where does it cross the y-axis? This is going to be that it's going to go up. Okay, if that was a fraction, it'd be going down. So exponential goes up. If that's a fraction in there, it's a decay, so it comes down. This one tells you initial value. Initial value. Look at this. Okay, look at those. So match those up. That's a kind of a fun activity to do. So make sure you do that. Describe the domain and range, so it wants you to plot and look at that. Check with your teacher what you're doing on this. Write the exponential function represented by the table or graph. You can do it by the table, just like we were doing. So try those. Pay attention right here, pay attention right here, and then use that. You know this is these are both exponential. So you're going to use initial amount, and then find out what's happening. What is the rate? On 20, here is a graph, and this is one that I could see showing up like on a standardized test someplace. It wants you to tell them information. Write the exponential function from a graph. Well, what's your initial amount? Look at your graph. What's your initial amount? Okay? And notice when I go up from here to here, how much do I go over? So I go over 1. How much do I go up? And that will help you figure out what's your rate of change. I went from 50 to 100. Then I went from 100 to 200. So you can kind of see, then I went from 200 to 400. Okay, so if you want to make a table and show what that is, and that might be helpful to write down these values, and then you can evaluate what's going on. You might be able to tell it from there. Okay, so that's what we want you to do for homework. So this is a page that we want you to work on for homework. Make sure you check on Schoology and with your teacher to find out exactly what your assignment is. Great. So now we have talked about linear, exponential, and quadratics and compared those, so you'll be prepared for that EOC test also. So if you have any questions, you know where to find us. Thank you so much.